Hello students, in this video I'm going to discuss some word problems on speed, distance and time. The basic concept for these problems, we should know the formula of speed, and speed is distance upon time, and from here if you want to find time, time is distance upon speed by cross multiplication, and the formula for distance, it is equals to speed into time. And the second type of problems we come across in speed, distance, time are upstream and downstream problems. In upstream and downstream problems, we deals with the two types of a speed. One is the speed of a motorboat, and second is the speed of a stream. Speed of a stream is also known as speed of a current. Now, if we consider the speed of a motorboat supposed to be x, and the speed of a water is y, so when we go downstream, speed is always increased, and it is increased by a factor of a y. That is the speed of a water. So when you go downstream, the entire speed, the total speed will be x plus y. But when you go upstream, the speed will be x minus y. It will be decreased by a factor y. So it means you have to keep one thing in your mind. So when you are adding and subtracting, adding and subtraction will be taken place of the speed of a stream. So x plus y and x minus y will be the speed during downstream and upstream. So let us try the problems related to this concept. In the first problem, A and B are 100 km apart on a highway. They are the two stations A and B. They are 100 km apart. A and B, the distance between them is 100. There are two cars. One car starts from point A and another from the point B. And they travel in the same direction. Means they are traveling the same direction at the different speed. Their speed is different. And they will meet in 5 hours. Now students, they will meet in 5 hours. Means at the point C they will meet at 5 hours. If they travel towards each other, they will meet in 1 hour. This is the second situation. So what is the speed of a two cars? So we consider here, let the speed of a first car is x km per hour and second is y km per hour. We are interested here to find the distance covered. Distance covered by the first car and distance covered by the second car. So in this question, we convert the question in terms of a distance. So with distance covered by the first car, this is equals to 5x. Since we know the formula for distance is equals to speed into time. Speed into time. Now speed for first car is x and time taken is 5 hours. So we get 5x kilometer. Similarly, the distance covered by the second car, it will be equals to 5 by kilometer. Now according to the question, we use the condition here AB plus BC. AB plus BC is equals to AC. AB is 100 given the question, BC and AC we just found. By substituting and solving them, we get the first equation as x minus y is 20. Similarly, in the second case, if they travel towards each other, they will meet in 1 hour. For second case, we have a situation, one car starts from the point A, second from the point B, they are moving towards each other and they will meet at the point C. Now here we find the distance covered by the first car, which is AC. Now in this case time is 1 hour, so we get x kilometer, and for second car BC is y kilometer. The same condition we'll use here, AC plus BC is equals to AB, where AC is x, BC is y and AB is 100. Now we solve 1 and 2 by addition. By adding we get x is equals to 60. Substitute this in equation number 1 and the value of y is equals to 40. So here x is equals to 60 and y is equals to 40. Now let us discuss another problem. In this problem, Ruhi travels 300 km to her home partly by train and partly by bus, and she takes 4 hours if she travels 60 km by train and remaining by bus. Now students, in this case here, we consider the speed of a train x and the speed of a bus supposed to be y. So we start the problem by considering the speed of a train x km per hour and the speed of a bus is y km per hour. Now if you understand the situation carefully, she takes 4 hours by traveling 60 km by train and remaining by bus. So total time is given 4 hours. So this 300 km has to be divided in two category here. In the first category, of 60 kilometer it is by train, and second is 100 kilometer. Second is 100 kilometer, and this 100 kilometer by bus. The speed of a train is x we consider, and the speed of a bus we consider y. So here this question we have to convert in term of a time. You know the formula for time, it is equals to distance upon speed. So in the first case here, the time taken during train, it will be equals to distance is 60 and the time will be equals to x. And for second case by the bus, it will be equals to, if this is 240, in fact this is 240, it is 240 upon y. Total time is given to you 4 hours, so we substitute t1 plus t2 is equals to 4 hours. So we're just mentioning here time taken in traveling distance by train 60 upon x, and the time taken in traveling distance by bus, it is 240 upon y. Total time is given in the question, it is 4 hours, so we have 60 upon x plus 240 upon y is equals to 4, which is equation number 1. Now in the second case, if she travel 100 km by train, 100 km by train means here it is 100 km by train, so rest of this will become 200 in this case. She will take 10 minutes longer. Now total time taken is 10 minutes longer. For 10 minutes longer, 4 hours is already there. For 10 minutes longer, we have a 10 upon 60. We'll convert this in hour. It is 10 upon 60. So by simplifying this, we get 25 upon 6. So second equation we can add directly. It will be 100 upon x plus 200 upon y is equals to 25 upon 6. Now we solve this by considering 1 upon x as a, 1 upon y as b. We get first equation 60a plus 240b is equals to 4. And second equation 600a plus 1200b is equals to 25 by cross multiplication. The first equation 3 will be multiplied with the 10. So we can cancel it easily. After subtraction, we would able to find the value of a and b easily. After subtraction, we get 1200b is equals to 15, b is equals to 15 upon 200, 1200, b is equals to 1 upon 80. The second case, substitute b 1 upon 80 in equation number 3. So we get 60a plus 3 equals to 4 and 60 is equals to 1. Value of a is equals to 1 upon 60. It means x is 60 and y is equals to 80. So therefore the speed of a train is 60 km per hour and the speed of a bus is 80 km per hour. Let us try another problem. In this problem, a train covers a certain distance at a uniform speed. If train would have been 10 km faster, it would have taken 2 hours less than the scheduled time. Now students, the two quantity vary here. One is the speed and second is the time. We will consider that x and y. Let the speed of a train is x km per hour and the time taken by train is y hour, and the distance will be equals to, it is speed into time, x into y kilometer. In the first case, if train would have been 10 km per hour faster, so we just going to find the new speed, that is x plus 10. It would have been 2 hours less, it will take 2 hours less, y minus 2 will be equals to xy. Now students, it is very important to understand here, if you increase the speed, time taken will be less, but the distance covered will remain same, which is equals to xy. So from here we get the first condition. By simplifying this, xy cancel, we get minus x plus 5y is equals to 10. Similarly in the second case, if it would have taken 2 hours, in the second case, if the train were slower by 10 km per hour, x minus 10, it would have taken 3 hours more, y plus 3 will be equals to xy, the total distance remains same. By simplifying this, you will get the second equation. Then you solve first and second equation. First equation you multiply with the 3 and then adding, you get 5y is 60 and the value of y is 12. Substituting this in equation number 1, value of x comes to be 50. So total distance covered, it will be equals to x into y, that will be equals to 600 kilometers. Now students, let us discuss the problems on upstream and downstream. As I already discussed here, in this problem, a boat goes 30 km upstream, 44 km downstream in 10 hours. It total time is given 10 hours. It means we have to convert this in term of a time. And it is asked to find the speed of a stream and that of a boat. So we consider that the speed of a boat in the still water is x km per hour and the speed of a stream is y km per hour. So when you go downstream, speed will be x plus y, and when you go upstream, speed will be x minus y. In the first case here, first we find the time taken during upstream. Time taken during upstream, it will be equals to distance upon speed. As we discuss here, upstream the distance is given in the question 30 and the time taken, it is x minus y r, will be this speed. Second, during downstream, 44 divided by x plus y. This is the time taken during downstream. Total time is given in the question 10 hours. So this will be t1 plus t2 is equals to 10. Substitute the value for t1, 30 upon x minus y, and 44 upon x plus y is 10. Now similarly, we can write the second equation. It can go 40 km upstream, means 40 upon x minus y, plus 55 km downstream, 55 upon x plus y in 13 hours is equals to 13, which is the second equation. We will solve this equation by considering 1 upon x minus y as a, 1 upon x plus y as b. So we get equation number 3 and equation number 4. Equation number 3 and 4 can be solved by multiplying equation number 3 with 4, because the LCM of our 30 and 40 is 120, so we multiply with the 4, and second equation we multiply with the 3, and then we do subtraction. We could able to find the value of a and b easily. 120a cancelled. We left here 11b is equals to 1. Value for b is 1 by 11. Substituting this in equation number 3, value for a is 1 upon 5. Then we have a x minus y, because 1 upon x minus a is a is 1 upon 5, so x minus y is 5. X plus y is 11. By adding them, you get 2x is 16, x is equals to 8, and the value of y is equals to 3. So therefore, the speed of a boat in the still water is 8 km per hour and the speed of a stream is 3 km per hour. Now let us try one more problem on this concept. Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. You have to find the speed of rowing in still water and the speed of a current. Now first of all, we consider the speed of rowing x km per hour and the speed of a current is y km per hour. Then the speed during downstream x plus y and during upstream it is x minus y. In the first case here, this question, Ritu can row downstream 20 km in 2 hours. It means this 20 km it is given to you distance and 2 hours it is given to you as time. So we use the formula of a speed is equals to distance upon time. Distance upon time for downstream. For downstream, speed is x plus y. X plus y is equals to distance is 20, time is 2. 20 upon 2 we get 10. Similarly, during upstream, it is 4 upon 2 we get 2. By simply adding them, you get 2x is 12, x is equals to 6. And substitute this in equation number 1, you would able to find the value of y easily. Y is equals to 4. It means speed of a rowing is 6 km per hour and the speed of a current is 4 km per hour. So these are some practice problems on this concept. I think the concept of speed, distance and time clear to you. Thanks for watching this video.